So how do we solve quadratic equations using the complete the square method? So the first thing you're going to want to do is you have to make sure your leading coefficient is 1. So if your leading coefficient A doesn't equal 1, what you have to do is go ahead and divide each side of the equation by A. You also need to make sure first it's definitely in standard form. And then you're going to go ahead, rewrite it so the constant term is alone on one side of the equality symbol after that. Then what you're going to do is you're going to add that b over 2 squared to both sides. So square half the coefficient of x, that's our b. And you have to add that to both sides of the equation. And the reason you add that to both sides of the equation is this is an equation. It's an equality. We have to maintain the balance. If I add a constant to one side, I have to add a constant to the other side. Then we're going to factor the remaining trinomial as a perfect square, x plus b over 2 squared. And then we can use the square root property to find the solution. So let's work through. I think I have 3 examples for us, then we're going to go through them all pretty slowly. So let's say I have x squared plus 8x plus 10. Step 1. If a doesn't equal 0, divide each side of my equations by a. Okay, cool. Next, rewrite the equation so that the constant term is alone on one side of the equality. So I'm going to subtract 10 from both sides. So I have x squared plus 8x equals 10. Next, I need to add b over 2 squared to both sides. I have to add b over 2 squared to both sides. Well, my b in this case is 8, so I'm going to add 8 over 2 squared to both sides. That gives me x squared plus 8x plus 16 is a negative 10 plus 16. This is going to factor perfectly to x plus 4 squared equals 6. And now I can solve using the square root property. I take the square root of both sides. X plus 4 equals plus or minus 6. So we can solve these. Let's go up here. X plus 4 is a positive 6, or x plus 4 is a negative, square root of 6. So I get x is negative 4 plus square root of 6, and x is negative 4 minus square root of 6. Quick hint, notice that our 2 solutions are conjugates. Interesting. All right, let's keep that in mind as we go through this chapter. And, friendly reminder, you need to rationalize all denominators. That means no radicals in the denominator. We know better by now. We learned about that in chapter 7. Let's switch to blue and switch to our second example. Okay, so I have x squared plus 5x minus 1. If a is 1, which it is, we can skip that step. Rewrite the equation so, I am the typo queen, y'all, so that our constant term is on one side, so I'm going to add 1. I've got x squared plus 5x equals 1. Then I add my b over 2 squared. Notice this isn't going to be so nice. Why? Because it's a fraction. But we're smart. We can work with fractions. So I have x squared plus 5x plus 25 over 4. It's 1 plus 25 over 4. This is going to factor perfectly to, remember it factors to x plus b over 2 squared. So I have x plus b over 2 squared, it is a fraction, equals 25 over 20, oh, nope, I don't want 25 over 25, I want 4 over 4. That's how we rewrite 1 with the denominator 4. So I have 4 over 4 plus 25 over 4. So I get x plus 5 halves squared is 29 over 4. I solve this by taking the square root of both sides, changing color and working over here. That gives me, oops. That gives me x plus 5/2 is plus or minus the square root of 29 over square root of 4, which is 2. So I have x plus 5/2 equals a positive square root of 29 over 2. And x plus 5/2 equals a negative square root of 29 over 2. That gives me x is a negative 5/2 plus square root of 29 over 2. X is a negative 5/2 minus the square root of 29 over 2. So I have x is negative 5 plus the square root of 29 over 2. And x equals negative 5 minus the square root of 29 over 2. Again, those answers are conjugates. All right, the last example for this section. We do not have a leading coefficient of 1. So we're going to have to go ahead and divide both sides of the equation by our a, which in this case is 2. So I have x squared minus 2x minus 5/2 is 0. I'm going to add 5/2 to the other side because I want my constant term all by itself. I'm going to add my middle term divided by 2 squared. Negative 2 divided by 2 squared is 1. I'm going to factor the left-hand side. This gives me x minus 1 squared is 5/2 plus 1, which is 2 over 2 is 7/2. Take the square root of both sides. So I have x minus 1, sorry, never enough room, is plus or minus the square root of 7 over the square root of 2. Remember, we got to rationalize all denominators. I'm going to go ahead and do that. So I have x minus 1 equals plus or minus the square root of 14 over 2 multiplied by the square root of 2 on the top and the bottom. So I can go ahead and add 1. So I have x equals 1 plus or minus the square root of 14 over 2. So x equals, if I write 1 as 2 over 2, 2 plus the square root of 14 over 2 as our final answer, so plus or minus. And if I wanted to, I could rewrite this out. I could write it as, okay, I've got x is 2 plus the square root of 14 over 2, or 2 minus the square root of 14 over 2, but writing it as 1 would work as well. And we're really going to see that as we talk about the quadratic equation in the next section.